This is our project. We can see that there are this is an LED matrix which is lighted 4x16, and this is the 4 sensors. So we are actually detecting 16 LEDs per sensor. This is the camera, and the sensor Arduino. The sensors are controlled with this Arduino, and the LED matrix are controlled with this Arduino. The this Arduino is used as a test bench for testing our project, and the whole setup is actually enclosed in a black box, so that to increase the threshold and not have the outside noise interfere. And we can see that this is an aluminum foil. This was actually implemented to increase the intensity level so that the upper row could be detected, and the whole system is now closed. And we can see that this is the wire. This is the wire from the Arduino of the LED matrix. This is the wire from the Arduino of the sensor, and this is the camera, and they are all connected to a USB hub and to the computer. So this is our setup. We'll now check if the camera are aligned with the LED matrix. We can see that the whole LED matrix is can be captured by the camera, and now we will close the camera and move on to the next steps. This is the test bench setup of our project. In the left hand side we can see we have aligned the camera, and in the right hand side we have written a script to control each individual LEDs and the intensity of the whole matrix. Say we want to turn a particular LED off, so we do this int of 7, say we can see that the LED has turned off, and if we want to on the particular LED, we do this int on 7,20. So the particular LED has turned on. We can turn off a particular row also, row off. Say we want to turn on this row, and then if you want to turn on this row, then we do this. If you want to turn off a particular column, call off, we do this. If you want to turn on a particular column, we do this. If you want to set the intensity to a whole another level, we do this, set int. Say the default intensity is set to a 0 level, and if you want to increase the intensity, say to 2, we do this, set in 2. We can see that the intensity has increased. We now revert back to the default position. So we now check the real-time data from the sensors. We can see that this is the data, and the sensors are pretty stable because there is no noise interference and the whole system is surrounded in a black box. After setting up our whole system, we now calibrate it. The whole system is the LED matrices are lit 4x16 with the sensors placed and the cameras placed. While calibrating, the camera will take one snapshot of the reference position, and the sensors will take the reference data. Now we run this. You can see it is calibrating. It has calibrated. Now comes the main testing part. We are saying for our testing purposes, in a particular time period, each LEDs are coming and these sensors are sampling it. If the sensor detects error, then it will pass the processing to the camera, which is a heavily intensive task. And if it does not detect an error, then the LED matrix has passed the test and it is free to go. So now we test it. We can see checking real-time sensor data against reference values. We can see, as we have not input anything in the test bench, we are see that the all LEDs are passing after a particular time interval. This time interval we are taking the time interval for for a particular LED to move into place. And now for testing purposes, we induce an error to a particular LED matrix, int of, say, in a random position. We can see that this LED matrix has failed and it has moved to image processing. After image processing, the system will generate a test report detailing what has gone wrong. It will only generate a test report if the LED matrix has failed. The name of the PDF is includes the which LED has malfunctioned and at what time. This has been done so that in a batch process, the manufacturer can identify a particular LED in a sample. So we now see what is in the LED report. We can see that which LED has malfunctioned at what time, and we can see that we induced a particular error in this position, and it has detected, and it has detected which LED rows has failed, and this is the particular test results. We can see that one LED has failed, and at what position. We can see this is failed missing LEDs. Okay, we now revert the LED back to the original position in dawn 5:20. This is the position that we set off. For our testing purposes, we also induced an interrupt so that we can continue our testing or close the program. So we want to continue our testing, so we type Y. We can see that the next matrix has passed as it does not have any error because we set this to the default value. The reference value has been compared with this particular LEDs as well. This shows the test results after a whole row has been turned off, and we can see it has detected the particular row, and the test status is failed missing LEDs. This is the test results highlighting if a particular column has been missing. So we can see that the missing column has been highlighted with failed LED positions. In this way, it can detect missing LEDs in every position. Now let's move on to the intensity part. We now see the test results if the intensity doesn't match. We can see although all the LEDs are present, the intensity is not within limit, so it has generated a report saying fail intensity not within limit.